Alright, so we're back for the last lesson in Unit 5B, graphing tangent and cotangent graphs. And again, you have a note-taking guide that you can refer to and follow along with. Alrighty, so these are a little different. They look a little different, and they actually don't take as much work in my opinion. But tangent graphs, they do not have an amplitude. The period, this is when it's different. Instead of 2 pi divided by the absolute value of b, it's just pi. And we're only going to have 2 critical points other than 0. Okay? The shifts still depend on C and D. You have a y-intercept at 0, 0 for tangent, and the flips are the same as sine. Okay? They look something like this. Okay? They have this little S shape to them, kinda, and then they have asymptotes in between them. So that's what you can expect with tangent. Alright, so here goes. Let's do our parent function. Okay? Amplitude, none. And we don't even need A for this, okay? Oh, let me write this out. Y is equal to 1 times tangent of 1x minus 0 plus 0. Okay? Period is going to be pi, not 2 pi, but just pi divided by 1, which is pi. And our critical points will be 0, and then pi divided by 2, and then pi. And for the parent function, we have no shifts and no flips here. Okay. So when we put this on our graph, we have this is pi over 2, this is pi, it's negative pi over 2, this is negative pi, and let's graph it. Okay, start with 0. The tangent of 0 is 0. The tangent of pi over 2 is undefined. And the tangent of pi is 0. That is one complete period. Follow the same pattern around here. So I have point, asymptote, and then point. Notice that A is not even needed to graph this. Oh my goodness, I don't know why that keeps happening. There we go. Okay, so you don't even need A at all to graph the tangent function. Alright, and tangent is always increasing. Okay, so it's going to look like this. Got a little S curve going on in there. Okay, that's what 2 complete periods look like. You can bring that on down here if you want to, but then that takes you to the left side of negative pi, which is technically not part of just 2 periods. Same thing here, you could come out like that, but it takes you beyond pi. And it doesn't matter, I wouldn't mark it wrong if you left it like this. Okay, just know that 2 complete periods is actually from negative pi to pi. Okay, now if this graph were to flip, okay, then notice that your points are all on the x-axis, so they're going to stay there. Goodness gracious, I don't know why I keep going there. Okay, so those points are going to stay there. The asymptotes, if they were to flip, the line would still be there. So really, if you have a flip, what happens is instead of the function always increasing, it's going to decrease. So it's going to come down like this. This is what it looks like if you have a flip. So just instead of it always being an increasing function, then it's going to always be a decreasing function. Okay? So this is y equals negative tangent x, and then this is tangent x. And again, learn your parent functions, because that's what that's how we graph all the other functions. Okay, so let's see what's going on here. Okay, no amplitude, period is pi divided by the absolute value of b. Critical points, the first one 0, and then we're going to take the period and divide by 2. Now remember, dividing by 2, dividing pi over 2 by 2 is the same thing as multiplying it by a half. So that'll be pi over 4. And then your last one's going to be the period, because you're going to multiply this by 2, and it's going to bring you back to pi over 2. Okay. Shifts, there is nothing inside, so no horizontal shifts, but we do have that plus 1 on the outside, so that's going to go up 1. And the flips for tangent do the same thing as sine. So if A or B are negative, then that means you're going to have a flip. So this one's going to flip. So let's see what this looks like. Okay, so I'm going to use X's and little tick marks for asymptotes and points. So on my parent function, I know that I would have a point at the origin, and then this would be an asymptote, and that would be a point, and then I would follow that on this side in the same pattern. Now, this has a shift up 1. So all of my points are going to go up 1. And of course, asymptotes cannot be shifted upwards, so they're just going to stay where they're at. And since we have a flip, we are going to make this a decreasing function. So it's going to come down like this. And that's all there is to it. These are easier, I think. Okay. Alright, be careful here. B is not 1, C is not 0, so let's factor out B. So still no amplitude, and we don't even need A. Remember, A is not involved with tangent or cotangent when we get to that one in the next problem. Period pi divided by the absolute value of B. So critical points 0, and then half of the period, and then the period itself. Shifts, it looks like we're going to go to the right pi over 2, and down 1. Oh, put that on the wrong thing. And do we have a flip? We do not. A and B are both positive. Okay, so the base graph for tangent has a point at the origin and an asymptote here. Point, follow that same pattern. Okay. Our asymptotes, of course, might be moved. Let's see. We're going to the right pi over 2 and down 1. Let's measure what pi over 2 looks like. Pi over 2 is actually the whole period. That's the length of it. Okay? And we're going to be moving to the right. So I'm going to go ahead this time and extend the positive x-axis a little bit here. Okay, so that's 1 pi over 4, 2 pi over 4, 3 pi over 4, and then 4 pi over 4, which is pi. There we go. Okay, and according to this, yes, I'm going to the right pi over 2, and then down 1. So pi over 2 is a complete period. Okay, so that means your asymptotes and points aren't going to change really, because here's your point right here, and if it goes pi over 2, then that's going to be 2 units to the right, this amount right here. So if I move this one 1, 2, then I end up here. If I move this asymptote, I'm sorry, I forgot to move it down 1. My dog is snoring again. She falls asleep during every video. I can't imagine why. Anyway, okay. So, right pi over 2. So, right pi over 2, and then down 1. That puts this point right there. Okay? And again, you don't have to draw this little diagonal arrow here. I just wanted to show you where that point went. So, this point to the right pi over 2, and then down 1. The asymptote to the right pi over 2, of course you can't take a line up or down. Okay, and then this point to the right 2, down 1. And then that asymptote goes to the right 2, so it moves right here. So you can already see this little pattern taking shape, right? That you're going to have an asymptote, point, asymptote, point. This is going to be an asymptote. So then I'll have a point right here. Okay. If you want to, you can put a point right there. So you can extend that second period to the right, or you can extend it back over here to the left. Ever how much room you have on your paper. Okay. Since there are no flips, then we're going to do the whole increasing from left to right. So this increases left to right. If you want to, you can start at the bottom. I just draw these things a little bit better if I start at the top. But I wanted to show you exactly what I meant by increasing from left to right. Okay. Alrighty. Now, Cotangent, same as tangent, except we're not going to have a y-intercept because x equals 0 is going to be an asymptote. I'll show you what I'm talking about. Okay, so let's do the same thing here. Let's say that we are going to graph the parent function for cotangent, so that's 1 times cotangent of 1x minus 0 plus 0. Again, no amplitude, even though a is 1, no amplitude, because we don't have a top or a bottom, a max or a min. We don't even need a, we don't even have the graph a. Alright, the period is pi divided by the absolute value of b. B is 1, so the period is just pi. Critical points will be half of the 0, half of the period, and then the period itself. See, I think tangent, cotangent are the easiest ones to graph. Shifts, C and D are both 0, so there are none. Flips, A and B are both positive, so there are none on the parent function, of course. Okay, I take you through that every single time because, like I said in the first video, when you have a quiz or a test, I'm going to give you these 5 blanks, and you've got to fill in the blank with something. The blank answers are wrong answers, so don't ever leave it like that. Okay? Alright, so, don't ever leave it just blank. Alrighty. So, let me see, here's x and here's y. Let's see what's going on here. Pi over 2 and pi. And this is negative pi over 2, and this is pi. Negative pi, I mean. Alright. So, cotangent. Start with x is 0. The cotangent of 0, undefined. That means you have an asymptote right here, where x is 0. The cotangent of pi over 2 is 0. And the cotangent of pi is undefined. So we'll have an asymptote there as well. Oh, I think I need pink, don't I? Yes, of course I need a pink asymptote. I can make that one pink too, but you know. Okay. And then follow that pattern on around here. And that's where your asymptotes and points are. And then cotangent is always decreasing. So it looks like this. So cotangent and tangent, yeah, they look alike, except for the parent function of cotangent is always decreasing left to right, meaning it's going down from left to right. You see how that's doing right there? Okay. And your y-axis is an asymptote. Okay. Now, of course, if you flip cotangent, your asymptotes and points will be in the same place, but cotangent will then increase instead of decrease. So it will look like this. It will increase from left to right. So this is what y equals negative cotangent of x looks like. And then this is the parent function. Okay. So then we've got 2 more. We'll be done. This one's going to be the short video of the week. Okay. Alright. Negative 2 cotangent x minus 1. No amplitude. Period. Is pi divided by the absolute value of b. B is 1 here, so it's just going to be pi. So my critical numbers will be 0, half of the period, and then the period itself. Shifts, no, nothing horizontal, but we do have that minus 1 on the outside, so that means we're going to go down 1. And we are flipping because A is negative. Okay. So I know cotangent is an asymptote unless I have a horizontal shift. So I'm going to go ahead and dot the y-axis. My critical numbers, pi over 2, pi, negative pi over 2, negative pi. And I'm going to be shifting down 1. So I'm going to go ahead and put my negative 1 down there because I know I'm going to be using it. And I just put a positive 1 up there just for the sake of my OCD-ness. Okay. Alright, so everything but the shifts. Okay, so remember, cotangent has an asymptote on 0, a point on pi over 2, asymptote, and it follows that pattern right on around. Now, the shifts, excuse me, I'm going to take all my points down 1. Asymptotes stay in the same place. Simply because you can't shift a line down, remember? So asymptote, asymptote, asymptote. Okay, now remember, your parent function for cotangent is always decreasing unless you have a flip, and since you have a flip, it's going to be increasing. So it increases from left to right, and it stays between those asymptotes, okay? It doesn't have to be perfect, y'all, okay? Just give me something that's increasing and don't make it look like a straight line, okay? All right. Let me see. Let's do the last one here. Of course there's one you have to factor. Why wouldn't there be? Okay? Alright, always double check about B and C. If B is not 1, C is not 0, you need to factor. Okay, now, oh my goodness, I don't know what in the world. There we go. Remember when I factored right here, I just divided this by 2. That's how I got x here, and divided this by 2. That's how I got pi over 4 there. Amplitude, none. Period, pi divided by the absolute value of b. Critical points, 0, half the period. Whoa, started to write something wrong. And the period itself. Shifts, looks like we're going to be going right pi over 4. And up 1. And do we have a flip? We do have a flip. Again, okay. Alrighty, so to draw this x and y axis, okay, I'm going to go ahead and dot the y-axis until I know for sure if I'm going to have an asymptote there or not. Okay, I actually know. I have this little method of figuring it out ahead of time, but I'm going to pretend that I don't know and go ahead and dot the y-axis. That saves your eraser. You know, just go ahead and dot it if you figure out, oh, it's not an asymptote. Well, make it solid. Okay. Save the life of an eraser. Okay, so for cotangent, parent function, asymptote here, point, asymptote. Follow the same pattern. Now we're going to shift stuff. Okay, the shift is right pi over 4. So this amount right here is pi over 4, right? Right. So everything's going to go just 1 unit to the right, 1 little pi over 4 unit to the right, and then up 1. Oh, I need to put my 1 up there. Oh, y'all know I got to put my -1 too. Okay, so this asymptote is going to go to the right 1. It's going to move to right there. This point is going to go to the right 1 because that's the length of pi over 4, and then up 1. This one is going to go to the right 1. This one to the right 1, which is, pi over 4. When I say right 1, I mean pi over 4 units, pi over 4, then up 1. And again, I can extend my graph over here, or I can just follow my pattern back over here. I'm up at 1 asymptote, 1 asymptote. Oh, looks like there's going to be a 1 right there. So now that I know where everything got shifted, I'm going to put my asymptotes here. I've got an asymptote here. I've got an asymptote there. It turns out that the y-axis is not an asymptote after all. Dun, 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 dun. Which I knew it wouldn't be. Ask me in class how I knew that. Okay? And now all I have to do is figure out which way those little waves, or those little S-curve thingies are going to go. Okay? Remember, your parent function for cotangent decreases left to right unless there's a flip. And in that case, it will increase. And there is a flip, so we're going to increase from left to right here. Increase. Oh, that's ugly, but I have to do. Increase. You see what I'm doing? Increasing from left to right. Increase. There you go. And that is all there is to it. Okay? Study. Don't get confused. Get it right. Okay?